Now I invite Mr. Rajesh Ramachandran.
Hope you can hear me okay, right? Good morning again. Thanks for your time today. And as Raman said, the second day is something makes it interesting and challenging, has the right audience. It's a great honor for me to be with you today to talk on an interesting subject, which is how do you get the business benefits by applying industrial artificial intelligence at scale? It has clearly been now that no more a skunk works project. We just heard from Anup the use cases where the AI is bringing the value. My topic is going to be how do you get the maximum benefits if you apply that in industries at scale? Not as pilot projects, but scale it. And what is it needed to make it scalable? ABB is a leader for more than 100 years on the industrial automation, electrification, and for more than a decade on digitalization. And my role at ABB as driving the digital strategy, the digital platform, and the digital business has something unique that my 32 years experience started with 6 years on the operation technologies, 12 years on IT, and last 14 years in digital. So I understand the pain points of what it takes to combine the OT and IT and ET to bring the value to business with digital. 4 topics. What is the role of industrial AI? How do you apply at scale? And some of the strong use cases where we saw in our global customers, including Indian customers here, saw the significant benefits of industrial AI. Talking about something that you cannot ignore, that you want to go ahead immediately. And the new disruption of generative AI. And we have a big role to play as ABB. You possibly saw the news that ABB and Microsoft have announced to have generative AI into the industrial applications. Let's start with something which we all understand, simple, right? 3 things that is making a big shift. License to operate, sustainability and energy transition. Open process automation, we saw quite a lot yesterday. And the digital transformation. That's a second shift. And the third is the globalization, which obviously makes supply chain, your manufacturing chain, and whatnot we talked about. In fact, this group in this room are possibly very fortunate because we have been in the 3 industry revolutions, right? Neither our ancestors, maybe not the followers, right? We were there in 3.0, we have been there in the 4.0, and we'll be there in 5.0 as well. What does it mean for us really? Today, we are at the cusp of maximizing the benefits of Industry 4.0, which is nothing but a data-driven way of driving, creation of a digital with cyber-physical system that makes it remotely operate, bring the benefits across different value pillars with digital, which is clearly where we are. But different organizations are at a different stage of reaping the benefits. And the companies that have already adopted this have seen a significant value. You have seen companies' valuation is going completely different than what they were 5 years back. Where we are already is going to the Industry 5.0. In simpler sense, it's nothing but mass customization or even personalization. That's what is about Industry 5.0, wherein we are deeply connecting the human centricity, which is called as a cognitive, to the AI. So it's data, but the domain is deeply connected, which is making what we call as the cyber-physical cognitive systems. Let's forget about some of these tech words. Bear with me, my doctorate is on industrial AI, but it's all about here, what's key importance here is how do you maximize the value of Industry 4.0 with AI? That's going to be the focus for this presentation. And of course, how do you make yourself ready as the early adopter for Industry 5.0? Take 3 years, go on the ground, these are all clearly the top shifts that we see it. And I'm sure that each one of you will agree. The business objectives or priorities have driven the adoption of industrial IoT and AI. This is last 3 years. Maybe if you talk about 5 years back, it was a technology people want to embrace, as Raj was saying in the morning that 2017 we talked about AI, nobody wants to talk about it. Today, AI, industrial context, industrial AI is a mainstream. If that is not being applied at scale, that means something being missed in your organization, right? It also applies for our organization in ABB. Second shift we see is the license to operate sustainability across energy, renewable energy management, circular economy, energy optimization, emissions optimizations, and driving the whole thing as a comprehensive, as we saw from Anup earlier. The third element is significantly growing is remote digital operations. We have customers who are operating the entire main, 1,000 kilometers from the main, completely using our digital platform and digital solutions to manage. So digital operations is possible today with industrial AI that ensures the cost optimization, safety for the people, as well as compensating the knowledge drain of the people with the aged workforce. As we also saw, the moving from a predictive maintenance beyond that, having a holistic asset performance management is possible today with industrial AI. That's being applied in many different customers. The focus of bringing AI, advanced analytics, the value of digital to the worker, to the service technicians, to the process operator is a key. That's going to be the key for digital transformation. That's a connected worker, which is another area we see a significant adoption. And believe me, we see hundreds of customers across the industries are now in global rollouts of industrial AI and IoT applications, not just doing POCs. So there's clear value, demonstrated value that we see here. Of course, for that, there's also technology priorities. The whole convergence of industrial AI, which I will describe in a minute a little bit more, with industrial IoT is becoming one or the same, right? It's AI, you get the data for industrial IoT for analyzing and optimizing and predicting, which is the AI. And of course, the shift is also happening from on-premise to the hybrid cloud. That means you run certain things on the edge, certain things on the cloud, certain things could be still on the data centers. The concept of industrial data ops, we are one of the leaders here, wherein existing applications that are available as point solutions you already have can be moved to this contextual data pipelines, which is going to make it faster to get the return on investments on the digital solutions. And we saw also a topic on AI at edge from my friend from Siemens yesterday. But if you look at the edge AI is clearly a key game changer at this point of bringing the models AI to the edge, making it closed loop. And in ABB, we are a leader here on providing the autonomous operations using the edge AI. And this morning also we saw from Anup that process digital twins, not only just looking at fancy 3D digital twins or the asset digital twins, the process digital twins at scale is making a big difference. Let's look at the role of AI is pretty simple in this landscape, right? People ask about, Rajesh, what's the difference between technology and digital, and what's the difference between digitalization and digital transformation? For digital, we all know that it all starts with data, right? We start with data. It could be a different data, OT, IT, ET, IoT, sensor, enterprise social, weather data, whatnot. But combine that with three elements, which is, it could be an IoT technologies, it could be a communication technologies that we saw yesterday. A domain expertise is critical, and the AI. AI could be a simple statistical AI, or it could be a deep learning and whatnot, right? That brings to the digitalization only. And I have seen that many customers are happy with doing this first part and see that I also have AI. And as we saw in the morning, it's not good enough. It needs to be then scaled. That needs also the next three elements. Start with the bottom, value engineering, right? What use cases is going to bring what benefits, what percentage? Am I ready with my data contextualization? Am I ready with my data readiness? The business models, digital is often to be a self-funding model. It cannot be a CapEx. I cannot go to a customer or as a partner saying that you need to invest $1 million for getting your benefits. It's not going to work. It should be a self-funding in 3 months. That's going to be a business model, either SaaS model, subscription model, or outcome-based models. Change management within the organization, facilitate as well. It's not giving a software, it's about making the change happen, the final value. It could be a savings of energy, or it could be increasing the safety, or it could be increasing the sustainability or asset life. It should be a change management along with the people. That's what we have seen that bringing a real value at scale. of driving the business outcomes. And this is something which is common, but just to get our basics right, the difference of AI and industrial AI is a combination of also using the first principle physics-based models which are domain-specific, which are brought by domains, along with looking at the data-driven. I mean, Anup was talking about operational constraints. How do you continuously bring the operational constraints into the model that you apply? That is what is actually the combination of industrial AI, which is the ensembled models, data-driven AI models along with the domain models. And it's today possible to do it in the platform, in the application. It's not about just doing it as a consulting exercise, or it's not something done as a separate human thinking. It's done within the solution itself. As we speak, the AI paradigm is shifting. And in fact, I was there in one of the launches for the generative AI a week before. People were started already referring old AI and new AI. I mean, whatever is not there in the generative AI is called as old UI. I disagree. We have two different AI. One that is helping us to advance the analytics, which is the analytics AI. You see the models here to be machine learning, deep learning models, reinforcement learning, vision. We talked about a lot yesterday. On the other hand, one that helps to generate content. Generating for me on a digital twin. Imagine that you can generate a digital twin. You don't need to build it. Imagine you can generate the images, generate the contextual text, contextual content, focusing on the languages or the content, whereas this focus was on the data. But imagine if you are going to look at both of them together. That's going to be the supreme value. That's what is going to make a difference for industrial AI at scale. Let's now focus on the left side in terms of what is available today as the industrial AI for analytics. How do we drive it at scale? The biggest learning that we had for last couple of years is that the value of AI is significant only when you apply at scale. Otherwise, we have seen, we can feel it good, it works, it makes a difference, we get a 4%, 5% improvement. That's not good enough. It's like saying that you have a treasure, but you don't go to the treasure, you see something in between and you get satisfied, right? You have to apply at scale, which means that it has to be in a scalable platform or solution. And as an example here for ABB, which is the ABB Ability Genix Industrial IoT and AI, which is integrated together. It brings all the 8 critical capabilities that ensures that your contextualized data for doing the AI is available all the time. It's not going to be just a POC, right? That's driving the digital value pillars. The consumption of that will be through the applications, the industrial data, digital value pillar applications across these 6 areas. The second element to be looked at is that a set of industrial AI models. What you see here is the actual use cases for which the models are available as examples here, which are using the AI principles underneath. It is no more about I just take a regression model. I'm not talking about a neural network model. It is to be applied for the use cases, for predictive maintenance, for operation anomalies, optimization models. How do you look at that for looking at prescription recommendations models? For specific kind of equipments, could be rotary, static, or instrumentation. All that is fundamentally an industrial AI models. And of course, the domain expertise is helping us to build this one. Example here, these are all the models of sample models available. There are thousands of models available from the Genix platform for industrial AI. We talked about digital twin. I have been researching on this for quite some time, but industrial AI can help you to accelerate adoption of digital twin. If we have to build a digital twin based on a physical model, first principle model, that's going to be a significantly difficult for us to build. It takes time. Whereas the AI models are helping to create the digital twins. In fact, that's one of the key functionality our customers are adopting at scale of Genix digital twin models of modeling that on top of the AI capabilities. It can be used very easily for the process digital twin to do it in a drag and drop model for the domain specialist. With this all, if you apply at scale, what you see the numbers here, the bottom is fundamentally the contextualized platform capabilities that unlocks the data, that brings the power of AI. The middle layer is the value pillar applications that enables for you to consume for different business use cases, and that brings the significant benefits across, whether it's for the energy efficiency, safety or operational efficiency, maintenance, asset reliability, and so on. Let me take quickly 5 use cases which are also seen as significant benefits across the customer deployments. And some of them, it makes sense for you to be with a solution provider who can provide at a scale as a SaaS solution. Implementing that just for one unit or one plant may be not bringing the value, because you might need to then take the pain of the whole cost economics of having a platform, applying the AI models, and so on. For ABB, this is a game changer. We have more than 40,000 gas analyzers that are getting the emissions data. Earlier, we used to send the service technicians to many customers. A lot of the customers here are our customers here on this solution. We used to send people who will do the inspection, who will get the emission data. Today, it's all digital. Data is coming to the cloud. The whole continuous emission data is coming. AI is providing, the industrial AI is providing on how do you predict anomalies, the whole emission breaches before it happens, increasing the analyzer performance to the 99% so that you don't have any regulatory non-compliance. And it is helping also to improve the safety and profitability for both customer as well as ABB, right? That's and one big benefit of applying industrial AI at scale. But if you're going to apply that just for a solution within a plant for, let's say, 25 gas analyzers or emission analyzers, you may not possibly feel the real value. It's better to get this at possibly at a very economical price points, but see the value. Right? That's an example of taking at scale. Another example, which of course, the first one is applicable pretty much for all the industries, right? Any industry that has the emissions, whether it is energy, process industries. The second one is about, we talked on the logistics, transportation, and vessels. This is also can be applied, and we have fleet services for critical assets. It could be for cranes, for various different assets, and so on. This one is, again, how to get the data to a scalable solution, and here it's provided as a fleet operating center for all the marine vessel operators. To get the data to plan on dynamic road planning, to get the assets that are being earlier managed by a set of domain specialists providing basic condition monitoring to provide industrial AI-based optimizations. That has a significant, the percentages that you see are impossible to achieve if you are going to be sitting with a bunch of domain specialists to create the value with simple AI models. It has to be at scale. This is a favorite example that how do you apply industrial AI for predictive maintenance, but it's not more the predictive maintenance. It can be applied across the asset performance management. The value of just restricting to the predictive maintenance gives you only about 10 to 12% maintenance savings. The moment it goes beyond, the moment it goes for asset reliability, asset integrity, and also looking at beyond health on performance parameters. We have 12 large customers today using this end-to-end asset performance for different industries, for the mining, for the hydroelectric power plants, for the large chemical plants, for semiconductor plants. We have seen the benefits that see is immense because you also look at performance, health, reliability using industrial AI. We talked about AI at the edge. Edge AI can really achieve at least 15 to 20% more optimization and value for anything that you achieve in your traditional APCs and traditional DCS optimizations. It's proven. It's proven for multiple use cases. I would sincerely look at you having discussions on us on what are the use cases we saw. That example here is that for the cooling systems, cooling tower optimization, it's clearly possible to optimize it using the edge AI for bringing the AI models deployed and optimized. The last one is everybody talks about when we talk about the AI system anomaly detections. Believe me, if you apply the system anomalies for not just for assets, for system of assets, for processes, we see a significant value. This is possibly one of the low-hanging fruits. To apply it, that helps on process quality deviations to be minimized. It can help on also ensuring that the operators are able to bring their operational constraints for operating limits dynamically. That, in fact, there is an ARC study says that only 18% of the failures of assets are based on the ages. Remaining 82% is based on the dependencies on the process set points and you actually operators excursions. They don't actually take the actions on time. If we actually use the system anomaly detection, in this case, the GenX system anomaly detection is used for hundreds of customers wherein able to bring any anomalies that can bring the patterns much in advance and almost cut down minimum of 50% of the unplanned down trips. Right? The industrial AI brings a lot of value even for process operators. We saw some examples from my colleague yesterday, Krishna Kumar, you would have seen. Here, whatever was the value on the APCs on top of the DCS is maximized further by adding the AI layer on Edge AI, which is bringing process anomaly detections, process optimization, managing the golden batch, and so on. I see the time, I'm trying to wrap up. All these values that you are seeing, you are on top of what you possibly have it as a CapEx investments on DCS or APCs. This can come by applying the AI solution. It could be a SaaS model. It could be also an Edge AI specific to your instance. That brings a significant additional. We saw as an example that using this, the OEE of a plant which was already optimized is bringing a 20% additional value on the loss preventions, on the opportunity loss, using the industrial AI. Again, applied for one specific plant, not even looking at an enterprise. I see that the big change for us to go to Industrial 5.0 is also with the power of generative AI. And ABP, we are leading as well as committed for bringing the context of generative AI in the industries. We are making a significant investment here to ensure that our customers, industrial customers, get the value of generative AI to combinedly manage and optimize sustainability, operational excellence, and asset reliability. People talked about yesterday from my friends from Petronas and whatnot. We can't just only look at sustainability. We will be then bankrupt because we need to look at sustainability along with operational profitability as well as the asset performance. That's going to be one of the key areas that generative AI can help on continuously optimizing both at enterprise level but also at even a unit level. One of the things that we'll be launching in next 4 months is to bring a GenX, which is our flagship industrial AI, IoT and industrial AI platform suite with the GenX Copilot, which brings a dramatic change in the user experience. Just imagine that you want to go on application, you don't want to even go and find out what is the critical equipment which is going to fail in next 2 hours and what should be the recommendation. You don't need to go to 5 pages in an application. You have a chat, you ask, it's just going to give you straight away. You don't need to build pages and pages on the applications. You need to have the services, the generative AI will create the pages for you. It will create the applications for you. There's an immense power which obviously need to be brought in the context of industries. That's what will be one of the key focus as well from our innovation side, along with working with Microsoft. So that's, to summarize, industrial AI is mainstream. Companies that are bringing this together in a scalable platform, providing either in a SaaS model or working with customer on customer-specific deployments, can demonstrate the benefits at a much higher scale than otherwise we can think of. It has a big role for making our economy safer, smarter, and sustainable. I'll be here for any questions you have it in the panel. Thanks a lot. Thank you.